Okay, hopefully everyone is back. I think we'll do a short recap, very short recap, just to make sure that we understand the concepts, because as we go, we need the knowledge of queries, variables, mutations to be productive and advanced. So just a very short recap. There's a schema language, contains types, queries, read operations, mutations, write operations. And the way you ask for that operation is presumably using hooks. Use this GQL parser to make sure that your query is validated against whatever you pass. So validated, I mean, but this condition that the limit is an int is checked. Whatever you pass for the variables, and the mocking or testing, we are not mocking low-level stuff like use query. That would be quite inefficient, to be honest. We are using the mocked provider, the tools that the library provides us, and then each mock has to be exact. I mean, by exact, I mean that the data, resulted data, has to be what we are really asking for, otherwise it will fail. Same goes for variables here. And with that, let's go to mutations. So we already learned about mutations, got a feel for them whenever we did the message mutation, right? So what we are going to do here is a simple exercise which will allow us to edit user's profile. And you will see a first glimpse of cache working correctly. And when cache is working correctly, it's not like it's broken or something. It just, sometimes it may be hard when you don't know all the stuff. And we'll see the cache working correctly. And you will see how amazing it is, really, because it really shortens our development time a lot. So going to the exercise number 3, our goal again is to write a mutation, a query, because we have to get the user data from somewhere, right? And then wire it up with variables. We learned about variables, so these placeholders, so that we can achieve the end effect that we've seen here. We also learn a lot along the way how the cache works. So let's start with writing a simple query. Again, I'm using the parser here, and this will be a very simple query, the user query. We already written that. Now we can name it. We should be, because we want our monitoring systems to be able to pick up the names of the queries, so we can pinpoint which component uses which query, and then maybe pinpoint the faulty component, or that something is broken when this query is invoked. Otherwise, what your monitoring system will see as just undefined as an operation name. There's a field called operation name, and it's very, very important that you should be naming your queries. So again, I'm going to go with a convention of exercise free user without the query, so I'm not redundant. Exercise free user, right? And I'm asking for a user, and I want first name, I want a last name, I want hobbies, and ID. ID is very important here, and we'll learn why just in a second. Okay, so let's try to use the query here to just render the component that we will be working on. So we already did that. Use query, pass the exercise free query, right? Okay, and of course I'm typing my data, so we'll get a user of user, and I'm taking data, I'm taking loading, and I'm taking error. And let's just name those fields. So user data, that's the syntax for renaming the destructured values. User data loading, and also user data error. I'm renaming them because I will be using also use mutation You'll see why. So I have these. I can perform my basic checks. So if user data error, return like a paragraph, could not get the user. Very simple. If user data loading, return paragraph, user loading. And of course, the optional check, again, up to you. I'm going to do this, not user data. So this is again, because TypeScript does not really have any chance to know that the loading state is correspondent, is tied, or I don't know how to really articulate this. You know, it's not tied with the data, right? So it doesn't really know that when the loading is false, the data is not undefined. TypeScript doesn't know, doesn't have that kind of information. So that's why I'm doing the check here. It will always be skipped here, and this check will probably never happen, but this is an artificial thing I'm doing, so that the user data is not null in this block here. And let's just render the component, right? So what's the component? User profile. User profile. Okay. Nope, like this. And user, it's user data user. Edit, on edit loading, false for now. On edit does not matter. Let's just pass an empty function. So now what we did a query without variables, but we named our query to make sure that it's visible on monitoring systems. That's just a best practice. You should be naming your functions, your variables, right? Okay, and now we have the user here. Of course, when we click edit, nothing happens. That's our next task. So mutations. Already wrote mutations. Again, the same trick applies really. So you can go to the playground and write the mutation here, update user with an input, but that's kind of cumbersome to copy and paste. I would rather just write it directly in the code correctly the first time. So mutation, and I'm writing again in another window. Okay, mutation, exercise, free user. And why I'm naming it the same? Isn't this weird that the names are the same here? Well, no, because this is a different operation. So there's no like overlapping names or something being redeclared. No. There are two different operations. Here I'm performing on the line 21 as a write operation. I will be updating something. And here on line 9, I'm performing a read operation, getting a user. So we can already specify the parameter because we know that there is the parameter here is, let me just update user input, right? It's of that type. Again, we are using the parser, it will be validated. So let's just write an input, the placeholder, the types has to match. If the schema contains the exclamation mark, I have to specify exclamation mark here. Otherwise, the query will not be valid. And update user, right? Input is the input. And we want to get back first name. Basically the same fields that we have here. Again, the ID plays key role, and you will see why in a second. And with mutations, well, there's a hook which is called use mutation. Use mutation. It works on the same premise as use query. The data returned is a bit different, you'll see. Exercise free mutation. Also, there's a property for variables. Again, they are not type at the moment, right? So that's kind of bummer. And we are returning an array here. That's the same thing as if you were creating a state. So state, set state, for example, right? So why is this an array? Well, I don't know. That's the internal decision of GraphQL Apollo client team. But the deal here is that the first parameter, first item in that array is a function. It's a function that when we will call, will perform the actual network request and write to the database. Well, not directly, of course, for a backend, but you get the idea. So I usually call it like update user, and then we can do structure. And here this object contains basically the same thing. We don't want data, we'll see why. We only want loading here really, and error. And again, let's name those fields. So update user loading and update user error. The errors here, I'm getting them on purpose because we'll be testing for errors. So we'll be performing a simple test to check if the error message is defined, right? So let's do it under here. If user update, oh, well, how about user user update user error, or and update user error, return could not update the user. Very simple. Okay, so we are getting close. We can now specify this property here, which is update user loading, but we are still missing this function on edit, right? So let's create a function, a synchronous one, handle on edit. It will take a user, and here we'll call the update user function. And we have to type it correctly. So the variables, see the variables here, I could specify them here, but I will actually not be specifying them. I will remove that in a second. So since this is an asynchronous call, we have to write it in try catch. And what we'll do is await update user. And for options, I can pass variables here. As you can imagine, it's much better than passing variables directly here. Maybe you have some static variables from props that you want to populate, because the variables from here that I pass here and the variables here will be merged together in the outcome when actually call happens, the network call. But since I don't have any kind of static variables or anything that I'm passing through props, I can safely remove this one. And see the variables here are not typed, not great. Again, let's change that. Use mutation, just like the use query function, is a generic function. That means it takes a type parameter. Just like your function can take parameter, generic functions or generic types in TypeScript can take parameters, but the types are the parameters, not values. So the input is input. Oh, the type is input, and the input itself is user. So again, why this notation? Well, let's see in the schema. Update user label input, and the update user input type. And update user input type corresponds to user. I just manually typed it in the user file. So we can pass the input here. Are the variables? Just let me input user. Yeah. And now I think that's actually, let me check. I'm not sure. Yeah, that's the second. That's the variables are the second, just like in a query, right? And so user. So first is the return data, the type for return data, and then the type for variables here. Okay, now, for now, we'll just ignore this because we are handling error here. And you can log to your system, perform like maybe retry, because there is a special parameter that you can take like refetch sometimes. Again, all in documentation, you will see it there, but we'll ignore it for now for all purposes. And now let me plug it in, handle edit, and let's see what happens. Notice that I'm not holding any kind of state. I'm not taking the result data here. So what will happen? Well, if I edited user here, and let's try my brother's name, Mateusz, it got updated. What? I'm not holding any kind of state. I'm getting my data from query, but somehow, some way, mutation influenced the query. So how does this work? And to understand how this line works, you have to go back to our presentation and talk a tiny bit more about cache. So remember that in memory cache, well, Apollo client by default caches all of your operations. And before you figure out that this may lead to some kind of memory leaks or basically your memory getting huge, there is a garbage collection in place, and Apollo is really smart. Don't worry, it's been battle tested by a lot of people. So the cache is pretty good. So it caches all your operations by default. And if you ever played with any kind of cache, there is a notion of key value pairs, right? Usually they are maybe normalized. That's something for another discussion. But the cache holds key value pairs, and we'll take a peek inside the cache of Apollo client just in a second. So the key of the value. In our case, well, ignore the type name for now. The value is just the thing that was returned from the query, right? Very simple stuff. But now comes the question. How do we create the key? Because that key has to be unique, right? Otherwise, we would be maybe in a danger of overwriting something, some different entry in the cache. So how do you create a key without introducing some kind of strict, opinionated way of creating keys, really? So the deal is that the key is a composite key. The notion of composite key means that it is derived from two things. So it contains two pieces of something together. And in our case, these two pieces are something that is called a type name. Well, the name is quite suggestive, right? It is the name of the type that I'm returning. For a user, it's user. For a message, it's message. That's coming from the contract, the schema defined by hopefully you and backend developers at your team, because you as a front-end developer should be involved in the creation of schema, because you are the client. You are actually the most important consumer of the API. And in our case, on a specific case, it's also the ID. That's why I told you to get that ID, very important. So the key is a type name. In our case, the key field is an ID. So what is type name? Again, as I said, it's the name of the type, user, message, very simple stuff, right? The concept is very simple. But the key field though, the key field is by default any ID on the type, any key that is named ID. So it has to be ID lowercase. Otherwise, it will not be inferred by Apollo by default. And Apollo is pretty generous with inferring stuff, but it has to be ID, or you can specify the key field for a given type in cache settings. But the most important thing I want to tell you about, really, because that caused a lot of headaches when I was first working on that large, for me at the time, first application. If you don't have a key type name and or key field, type name can be disabled, key field usually inferred, you will get no automatic state updates. And we just basically saw an automatic state update. And you really don't have to know that much to reap the benefits of automatic state updates. You actually may build a whole app without even knowing that there is something called type name or key field. But when you get to the point where something is not updating automatically, well, then you are in trouble, because you will be digging through documentation without knowing what's going on. So I want to save you this confusion because, well, I went through it. So I hope that with this, I will be able to save you some confusion. So let's test my theory. Let's say that I remove the ID here. I'm not changing my cache settings. And let's see what happens. Let's try to edit the profile. It didn't get updated, see? Because there's no key field. The type name is there. The type name, well, I don't have to specify the type name here, right? And that's good, because if you look at the schema, there is no type name in user. That wouldn't make any sense. Why? Because, well, my domain logic or domain things does not contain type name. My user has ID, maybe email, and things that I use for my domain logic. See, the type name is a field that Apollo client, as far as I know, well, as far as the only Apollo client, attaches automatically for every query, every type basically that you pull in. In our case, it's user. And it reads the type name from the type name or what we are pulling, right? So type name user, because the name of the type is user. Okay, so the type name is provided by default. I'm not using ID here, no automatic updates. But what happens if I remove the ID here? You might think that the user will not get updated. But it got updated, right? Quite weird. So this is where the notion of Apollo being really smart comes in. Apollo will automatically update as many types, as many operations as it can for you, even if you mess up and you don't provide the ID type. And there is a way. You might ask yourself, well, what if my backend developer or overall my schema doesn't provide ID types? Well, again, you can specify other types in schema, or you can plug them dynamically. That's more an advanced usage. But just know that for the simplicity's sake, whenever you are working with someone with GraphQL, you should provide the ID types if feasible. Otherwise, they can create their own. But if you have simple types like here, user, ID should be a no-brainer when it comes to creating a schema. So this is the automatic updates. So remember the key field, the thing that directly makes your type or your type unique. So I told you that we'll take a peek into the Apollo cache. So let's do that now. Oh, I'm in private window. Well, that's a bummer. Just give me just a sec. There we go. Let me go to the localhost. Yep. Because I mentioned the extension you can download. It's called Apollo Developer Tools, and will basically display you the cache, the current cache. So as you can see, let me just perform some operation like Mateusz. And look, type name, user. Oh, let me zoom in on that. Oh, I cannot. I hope that you can see something. Maybe I will just copy this to the editor. Whoops. Yeah. So in Apollo cache, this entry was created. Again, ID. I decided to include it as static 1 and the type name. And the entry is the data returned from our mutation here. And the data in the cache is normalized. I'm just giving you now leads because I'm not be talking about this because I don't think that you at this stage should know this, or we're not going deep into cache normalization or anything like that. All you have to know, if you have ID, then great. If you don't, and you want automatic updates, use a key fields on the cache itself. There's inside of the documentation, you can find the correct, the options. So let's write a simple test. Let me close this window. Okay, and yeah. Let's write a test for a mutation. We already written test for queries, so let's go with testing that the user can click this button, edit, and then change the name, for example, to whatever we see fit. So going to the third test file for the exercise 3. Okay, so we see two test cases, one from happy path, one from sad path. Let's go with happy path for simplicity's sake for now. And we can start with creating our mocks because, well, we know that we will be not mocking low-level stuff like use query or use mutation. We have to specify mocks. So first, query mock, mocked response. We already seen that request and result, right? And which query? Well, I know which query because I exported it. It's this query. I want to provide a mock for this query. There we go. Oh, let me import that then from exercise 03. There we go. Actually, I can merge the imports here, and we can also import the mutation. Yes, we'll need that as well. So are we putting any kind of variables? Oh, sorry for this. Are we putting any kind of variables? Well, no. So we don't have to specify them, but we have to specify the data and the exact shape that we expect inside the query, right? Because otherwise the test will fail. So we expect user. Oh, I'm not writing GraphQL now, I'm writing JavaScript. First name of, for example, Wojciech, last name, for example, Matuszewski, ID of one static, you could specify whatever you need here, and hobbies of GraphQL, for example, QL. Okay, so that's our query mock. Now let's specify our mutation mock or the successful mutation mock because we will be testing two cases. So successful mutation mock. And I'm pretty sure, well, I hope that my spell checker will tell me if I did any kind of mistakes. So the mutations for mocks are very, very similar because they are basically the same operations. They are just handled differently on the backend, but from your perspective, well, query is just gives you data, and with mutation, you can post data, get data back, right? So the structure is the same, request and result. And you also have to specify a query. So why not mutation, for example? Well, the query is a bit overloaded term in GraphQL in general. It means different things in different contexts. In here, in mocked response, so the mock that we are producing, the query just means any kind of operation. It can be subscription, it can be a mutation, it can be a query. So here, just a query and paste it here. Variables. Now, this is kind of important, right? Because as we are updating the user here, we are passing some variables. We are not defining them statically here through this optional second parameter, but passing them here. And remember, we have to be exact. Otherwise, well, the test will fail. So let's say I want to write an input. Why an input? Because again, I'm following the shape that's in my variables. And let's say I'm changing user's first name. So first name will be Mateusz. Last name will be Matuszewski. And ID will be 1. Actually, we are not passing an ID. We'll see. Hobbies. I want to stay GraphQL. Okay. So I'm not passing hobbies. Why? Because look at the shape of this, this type. There's no hobbies here. I'm not passing hobbies to this function from this handler. So that's why I'm not specifying ID here in the input variables. If I were, this would fail because there is no one-to-one match. It has to be one-to-one match. And the result, well, the result is data. And let's follow the structure now. The result is data, and then we have update user. It takes parameters. Here it's kind of straightforward, right? Because it's user and then the data. See, we have to follow the same convention here. So instead of writing user, we have to write this key. Well, this key will contain our results, this update user key. There's a correlation between the user and the update user key. So update user, look, there's a user here, update user here. That's because the operation has a different name, basically. The field is named update user, not user. So that is why I have a different shape of the data. An update user, well, it hopefully contains this data, but we've changed name, right? That's the response from my backend here. With these two mocks, we can start writing our first test. And again, it will be very similar to what we've written before. So first we render exercise 3, already important. Well, actually, we have to mocked provider, right? Then exercise 3. We specify our mocks. And you may be wondering, is the order does the order of mocks that I specify here matter? No, no, no. The number of them matters. If I were to specify only a query mock and perform a mutation, so click on the button that saves, well, the test will crash because there is no more mocked responses. So query mock, successful mutation mock, 2 mocks. Okay, and again, the same principle. Await, wait for element to be removed. Why? Well, here we are waiting for the data to be removed. So for the loading, right? So I could basically change it to loading, for example, with dots, whatever. I'm testing if this piece of code is no longer visible. Then I can test behavior on this component. So takes a callback, screen, get by text, pretty simple. Loading, I'm using the regex notation again. I could be doing something like this, but it's just faster for me to write loading. Great. So the loading was removed. Now we can assert on this one, or basically click the edit button. We'll be clicking now this edit button throughout using our tests, right? So user, again, writing in a different window, user event, click, and well, screen, get by role. Now this is a new selector, and there's something called accessible roles in HTML. If you are web developers, you are probably familiar with the notion of accessibility, and the specification of accessibility also contains something that is called roles, accessible roles. Some of the elements like form, buttons, paragraphs, headings have roles of, for example, heading, for example, button, right? So I'm using the role here because it forces me to, instead of creating a div that looks like a button, use a button. So get by role, button, and the name is, well, it's what's the button, it's the button contents, the text. So it will be an edit. Again, using the regex notation, let me check it contains like edit profile, but I just want to edit because it's faster to write. Okay, edit, then user event. Well, we want to change the first name, right? So type, it's an asynchronous operation. Type, selector here. Screen, get by label text. Again, labels used with inputs, pretty elementary stuff. I think the name is first name, and what we want to write? Well, we want to write Mateusz, right? And then we want user event, click, screen. We want to submit the form, get by role, button name, I think it's submit. Let me check. Edit profile and submit. This is where we at. And now, well, what do we want to do? We want to make sure that the form is not visible, this form. Otherwise, asserting here would be kind of weird. Like imagine you have a situation where an error happens and you don't close the form, but you like pop up maybe some message to a user, and you write Mateusz here. You click the submit button in your test, and then the error pop-up comes in, but you're asserting that the Mateusz is in the document, for example, right? So that's not good. We have to wait for this form or maybe submit button to disappear. That means just stop loading. And what we will do, I think, we can actually make sure that we can do two things. I'm going to go with a wait for element to be removed. I'm going to wait for the submit button to be removed. So screen get by role button with name of submit. And now, well, let's see. The debug method allows me to basically check in on the DOM while I'm testing. So it should hopefully update my cache, right? And it should hopefully display me the Mateusz. Well, we'll see. It's not that simple. Sadly, the mocked provider has some limitations. And as you can see, the first name is still Wojciech, not Mateusz. Well, okay, so we have the key field. But where are the type names? Are they added? Well, they are added explicitly by this mocked provider. There's a prop called add type name, and it's by default true. But this is a bug I found while preparing this workshop. You have to specify the type name directly here. So I'm returning a user here, and also here I'm returning a user. So type name user. That's just unfortunate bug. So and this should make it pass, I hope. Yes, and we'll see that there we go, Mateusz updated. And this is how we test in isolation that the cache automatically updates the queries, basically the state of our components. So I can assert that just to make things clear, expect, right? We just want to make sure that the Mateusz is displayed basically. Screen get by text. Well, let's go with manual, like literal string to be extra sure to be in the document. And with that, we have our test passing. So this is how you test, again, the successful case of test updates, query updates within your components in isolation using this type name field here. It's something really unfortunate. I hope it gets fixed. I think there is an issue for that already. So that's that. Now let's focus on the error case. So what we want to test is, is this case, could not update the user. We have to force the mutation here to flip the error flag somehow. Again, we are not mocking low-level stuff, otherwise this would be a nightmare. So we wrote a successful mutation mock. Now let's write const error mutation mocked response. And the shape is very similar, request and result. Now the request is the same. We are clicking the same button. So request, we can copy it basically. There we go. Let me just copy it, paste. Yep. And the result. Is there any data? No. The data is null when an error is returned. And this is why if you, I don't know if you know this, I'm always checking for errors first. I'm not checking if the data is nothing, then doing something. I'm always checking if the error is first. Again, this is because TypeScript cannot know that the error is somehow related to data returned from this field. There's no connection between those in types. How would TypeScript even know about this? So here we can return an array of errors. And what's interesting about GraphQL is that you can have multiple errors. Well, in REST, usually you have one error returned, right, with a status code. Here, believe it or not, depending on the error, your status code will be 200. You might have validation errors that you want to pass to clients from your backend, and you are not throwing like a server error or something really bad happens. You're just throwing validation error, or just passing validation error. The response is 200, but that shouldn't influence any, that shouldn't take any influence in how you test or how you write your components, because if you specify errors or if you return errors, this error flag will be flipped to actual errors. And if you see there's a specific type, Apollo error. Now, the errors can be an array, and we'll handle only one error for now. The error handling is pretty simple, but I just wanted to show you how to test for errors, because error handling is really universal, not universal, but something that you and your team decide to do. Maybe you are pushing to logging systems, or I don't know, retrying, displaying any kind of pop-ups, something like that. So let's populate with GraphQL error, because there are two error types. It's kind of unfortunate. Again, we are pushing the native GraphQL types, and the Apollo error type is a wrapper around GraphQL error. And we can pass like a boom here. That's my favorite, that's my colleague's favorite error. Okay, so we have the mock, and notice that the variables has to match as well. Otherwise, you will have a faulty test. Since if the variables will not match, this flag will also be flipped, because the validation of this GQL parser will fail because the type is not matching. But you are not testing for the error here, but you are testing for missing data, basically. So be very careful. And we can copy and paste most of our test here, really. We can copy and paste it, basically. The whole, like the whole test, change the mutation here, error mutation mock here. Okay, so we are waiting for loading. We are clicking the edit button, submitting, and now here, what we want to assert on is expect screen, okay, by text. Well, we want to assert that the error was displayed here, could not update the user. And again, we can go with literal form just for making sure that we are testing the error, and it's not someone writing like a div here with could not update user or something. Okay, so let's run the test. And hopefully, yes, they all pass. So this is how you test an errors. This is an Apollo error. There's also other class of errors. You can specify error here. Kind of confusing, I know. That's a network error. This is where your API responded with 400, 403, something like that. Connection fault, something like that. But usually we'll be using this. And okay, so we have tests. That's pretty nice. We are, getting along, writing our feature. But you notice that there's some kind of duplication here, right? And this duplication is kind of suboptimal. If you have many queries, very careful here. You don't want to over encapsulate stuff. You don't want to create abstractions for everything. But here it's understandable, right? Because we are in the same file, presumably, and we have this set of fields. So how do we abstract something in JavaScript? Well, usually what we do is either write a function for it, like get user fields, for example, and return an object. You can easily change that. Or maybe you gather stuff in just an object, user fields, right? And first name, however it may look like, that's not a valid syntax, but you create those containers, right? No Docker, containers in your code for encapsulating, removing duplication, if you will. We've seen that, we've done it throughout our careers. And there is also a way to do that in GraphQL. There is a special thing that is called a fragment. As the name suggests, fragment is a piece of types fields. Well, it can be every type that there is on that, every field that there is on that type, but it can also be just first name, which you share throughout your queries. Very careful here, because if you create a lot of these, you will be asking for much more data that you really need. You may be tempted to create a user fragment, which contains every field of user and use it throughout your application. Well, as good as it may sound that you just have to write one thing, I will show you how, it will lead to overfetching. You don't want to overfetch. You are using GraphQL for savings on the network, for faster network responses, for saving users' battery, for developer experience, but that I digress. And you don't want to pull every field possible, basically turning your GraphQL endpoint into a REST API. You don't want to do that. But here it's understandable. Again, same file. We can abstract some of these fields. So let's write user fragment. Again, we are using the same parser. And there is a query, there is a mutation. These are like reserved names, just like function, const, variable in var in JavaScript. Well, there's also a fragment. And it has to be named user fragment. I usually name it user fragment or something fragment or just user, but the user will be confusing here. Let's go with some duplication of the naming. So user fragment. And it's on user. I'm creating a piece of fields on type user. I want to get some fields, encapsulate them in this fragment, and these fields are coming from the user type. So first name, last name, hobbies, and ID. And I encapsulated the field names in this variable. It's just as if I wrote a user fields object. Of course, not a valid syntax, but something like this. First name, last name, hobbies, and ID. And then you can imagine that whenever you call a user or have a function like get user, right? You want the fields here. So you just pass user fields, right? Something like that. But now we created this encapsulation abstraction using fragment, GraphQL thing, GraphQL construction. So now we can remove this and also remove this. And you'll see the notation is pretty fun. So what you do, just like in JavaScript, you would spread some types, right? You would spread some properties, right? So just like in JavaScript, you just spread the keys that you want to get. This unwinds the keys from this fragment that I created. Same here, user. Now, notice that the user fragment here, the name, exists in the context of this GQL. It's not something exposed to JavaScript already. It will be passed as an argument to the GQL function. Again, that's a function, tag functions. We've talked about this. But I cannot really write it like that without adding something. So again, this is the power of the GQL parser, that it allows you to specify the fragments. Yes, you can merge multiple fragments, and then they can contain the same fields, but there will be no duplication. The fields will be like deduplicated. Yes, they emerge, yes. So user fragment, and now this GQL parser is just a syntax thing. Can look up the definition that I'm asking for user fragment, go here on this line here. Of course, this is a mental model. That's not something that really happens. And unwind the definitions here. And I'm telling it unwind it because this is not a valid syntax. This will be asking for a key, which is named user fragment. And we don't have that in a user. You have to unwind them using this spread notation, basically. And the same thing goes from here, user fragment. Okay, and this is really how to abstract some of the fields. If you are feeling that you are copying and pasting a lot, but remember to fight with the urge to create the master or the meta fragment for the type and just pull in every type, because every key, because you will end up really creating a REST API from a GraphQL API. And I've been there. I've done that, and I've seen it on production as well. So now everything works as before, right? But our API or surface area, basically of our components, is a bit reduced because we got rid of repetition. The mental model, or basically you're allowing developers to have less mental, gymnastics with your API, because, well, I don't know which fields on the user there are, but I see a fragment. Okay, I can go to the definition of the fragment, but I don't have to know that there's a first name, last name. Okay, like I will check it later. I implement my feature now, right? It works. Just leave it like that. And this is great. This allows you to again encapsulate some of the key fields as a shareable const. And you can export that. You can import it in different fields. So that's pretty good. Okay, so we went through creating a mutation, testing that, a lot of work. We have one more exercise to go before the break. And what we'll do is to generate types. And as you can see, use mutation, specifying those types is kind of cumbersome, isn't it? And especially here, you have to type anything manually, everything. User, if it changes, if the API, if the contract changes, and it happens, the contract can change. So I could add, as a backend developer, I could add a field to a user and then push it to production, and it shouldn't break anything. That's because the GraphQL is easily extensible. So you can change the schema. Of course, if I delete that user type, there will be production issues. But I can also, for example, add, I don't know, shoe size, for example, whatever, right? And now, well, look, I'm looking Sat Panda. My type is outdated. Not good. I have to manually update it, and it will take probably a lot of effort. So the answer to this is type generation. You can generate TypeScript types and more from your schema. So this is where this tool comes in. Let me just bump up the size. And there are a lot of tools to generate types, but I'm going with this one as I'm the most familiar with. Basically, it ends up being a YAML file with some plugins that you have to specify. It's very, very simple. And I will show you the file because I don't think there is much to learn when it comes to creating that file. It should be self-explanatory. So there is this exercise directory, final, and there's a codegen directory. And if you open it, it contains a file, a YAML file, which this library, GraphQL code generation will look at and generate types for our operations that we defined in components. By operations, I mean, for example, this query. This query will have its own types, and this mutation will have its own types. Pretty good. So by looking at this file, we'll generate the types into the directory I specified. So the schema, I have to point it somewhere. Where is my schema? Well, my schema at the moment is exposed by my backend, and you have to specify this header. I know, pretty silly, secret, but it's just there. And what kind of documents? So again, query mutation, query is very overloaded. Some people call it documents. So basically that means a document is something that you wrap with this parser. A document can be a query, can be a fragment like here, or can be a mutation, or can be a subscription. So where can I find documents? And I have some examples here, some files listed. And in our case, this will be src. For example, we can go exercise 03 at the entry here. So look for documents, again, things that are parsed with the GQL inside this file. And it generates the types to this file. I will open that file in a second using these plugins. And again, it's all listed in documentation. I don't think that we should go through the documentation really, because it's boring. You can read it. There are 3 plugins that you need. This one generates types. This is a helper for the TypeScript one. And this is basically telling the tool that I'm using Apollo, because you can use other clients, right? And this is the configuration. So what comes out is something quite big. So this file, as you can see, it contains a lot of stuff, and it is quite hard to read. You should commit this file, but you shouldn't need to look here. It's automatically generated. I think it should have like a string, automatically generate, do not touch, something like that, right? Either way, it creates a lot of stuff which is useful for us because it's fully typed, and the types are kept in sync. Yeah, of course. But the types are kept in sync with our operation. So there is you shouldn't be worried that your types will go outdated. And writing the manual types is just like, it's not good. Like you shouldn't have to do that. So let's generate types for this component, and I will show you how much code we can delete, or not code really, but how easy it is to use it. So let's run yarn run codegen. Of course, let's hope it, well, of course, it's not able to parse. All right, yeah. So when you generate the types, see, the naming here has a different, there's a different operation, but the parser itself, the codegen is not that smart. You have to specify the other name here than the exercise free user. That means that each of your operations has to have a unique name. It's actually quite good because it forces you to have unique names, which can help you debugging things. So let's go with exercise free user. Oh, let's go exercise update user, something like this. Okay, and now let's run the codegen. It generated the bindings, and well, the naming of them will be quite weird. Like you will see, it takes some time to get used to the naming of the variables generated, of the types. But again, it's extensible. You can specify naming convention in the YAML file that I show you, like in the config. I didn't, because I just go with the default here. So what we can do now is something that is quite remarkable, actually. So let's import from the codegen file generated. And what we can pull is something called use exercise-free update user mutation and use exercise-free user query. And you see the name corresponds to what I named the operation here. Let me just, there it is. Exercise-free update user, wow. Use exercise-free update user mutation because the operation is mutation. Same thing goes for query. So what we can do now, that's pretty excited. So what we can do is just delete all of this, all of it, like this whole thing, and just write use exercise-free user, and that's it. And look, it's correctly typed. And now you generated code bindings. Oh, well, let's say I don't want to use the generated hooks. I just want to use the raw use query, but I want this parameter to be pulled from the types that I automatically generated. Oh, use exercise-free. Oh no, exercise-free user. Oh, there is a query result, query variables, and the query itself. The query itself, again, the name is quite weird, but you can get used to it and you can change it. The query itself, the type of the query, describes the whole data that I'm pulling, everything that I can possibly pull, or everything that I pulled in the query. That's the correct name. But I'm going to stick with auto-generated hooks because, well, it auto-generated hooks for me, which are correctly typed. Like, mind blown, right? And it saves so much time. You don't have to write any kind of definition. So use exercise-free query. I just call it. I don't have to pass the, look, I don't have to pass the query. It just knows that it implicitly passes the query for me. It's auto-generated. And for the mutation, same thing. Use exercise-free mutation. I don't have to pass the query. And look, update user is correctly typed. If I remove the user here and use like a string, see, it's correctly typed. It's giving me the type name from my schema. Pretty nice. So update user. Oops, sorry, I closed that file. Okay. And with that, everything should work as expected, but I think we generated somewhere, where is the, oh, there it is. String or no, oh, yes. So again, I typed the user here, which, let me go, oh, here. I typed the user here wrong. See? I made a mistake while preparing this file. That's because I didn't use auto-generated files. And why it's screaming at me? Well, if we look at the schema for the user, see the hobbies here doesn't have this exclamation mark. That means it can be null or undefined. So what's happening here is auto-generated types correctly said that the hobbies can be string or null or undefined. Again, probably saved me from a bug. For the simplicity's sake, I will just go from any here because that doesn't really matter at that stage. I just wanted to show you that you can auto-generate code. You can save yourself from bugs. Don't do that. That's only for the workshop purposes. And you can do that with one simple YAML file. As far as I know, you cannot write JSON there, just YAML. So with that, we created a mutation, we tested it, we auto-generated code, and I think we are ready for another break. We'll do cache next and end the workshop. So let me pop up the timer and we'll see just a sec. We'll continue in 10 minutes, just like before.